There you go. So is my screen visible? Can you guys see it?
Yes, sir. Kita naman po.
Okay, great. All right. So first thing is, of course, I'll just introduce myself, though I'm pretty sure that you guys already know me. So here's my complete name. My name is Daniel Paul Saavedra, and then still the same for past 2 years. So this is about me, and then I graduated at UC as a computer engineering, and then here are some of my areas of interest, which still the same for past 2 years. And moving on to the homepage itself. So this one is pretty similar with the laboratory. So we have here the welcoming message, short welcoming message about me again, and then course format of this subject. So let me just change this one because this one was supposedly just a few, yeah, just a pure ODL. We don't have limited face to face for this one. Course, there you go. And then here is the course overview of this subject. So this course covers the study of microprocessor and microcontroller systems, including their architecture, component organization, programming and interfacing, and it specifically explores the use of 8089 microcontroller and Arduino microcontrollers. Okay, so at the end of the day, let's see, once you're done with the subject, you'll be able to utilize the general purpose input and output GPIO of microcontrollers for digital circuits, and then you'll be able to use the analog and serial ports of microcontrollers for digital circuits communications, and then lastly, you'll be able to develop microcontroller-based digital circuits. So we only have three for this one. And as for now, we don't have available ebook, so I haven't found one good ebook yet. So I will just update this one probably within this week. Okay. And then for the netiquettes, so these are just the things that you can do and cannot do inside of our class. Okay. So I think there is no transfer, so there is no need for you to watch this video anymore. So yeah, that's pretty much it for the homepage. So are we clear so far? Any clarification or question? Hello?
Wala naman na po, sir.
Give me a quick thumbs up just to let me know that you don't have a question. All right. So hello, Mr. Gapus. Mr. Daryl. So I believe that this is his probably call this one parang alternative subject since Mr. Daryl is actually a civil engineer. So he is not a computer engineer student. Anyway, are you here right now, Daryl Gapus? Anyway, all right. So for the course syllabus, this one is blank. Okay. So I'm still asking for the latest syllabus from Ma'am Karen, since she's the one handling this one for the past 2 years or 3 years, I don't know. So yeah, I haven't got the syllabus for the microprolec and lab yet. So I'll just update this one soon once I have the syllabus for this subject. Okay. And then I guess there's no need for students orientation anymore, since this is for, let's say, transferee or first years doesn't know how to navigate here on the canvas. So I guess we can now proceed to the modules. So for the week zeros, everything is pretty much the same. So I won't be explaining these things anymore. So I will just remind you guys that please submit your 1 minute video. So though the due date will be until June 2, but right now there were only 4 who submitted their introductory video. So as soon as possible, please submit them so that I would know what would be your expectation to the scores and to me as your instructor. Okay, so are you guys ready now for our week 1 and 2 for the module 1? No,
Yes,
hello.
sir.
Makain na yata kayo ng lunch eh. Anyway, so as you guys can see, we have a different format from what I'm using. I used to, have in our courses. So again, 99% of the content of this subject came from, I don't know, maybe it's a combination of Ma'am Tere and Ma'am Suarez. So only 1%, some changes, some modifications are made or done by me. Okay, so the rest, they came from Ma'am Tere or Ma'am Suarez. So it's a disclaimer for this content of this one. So here is the topic learning outcome. Okay, so here's the format that Ma'am Tere or Ma'am Suarez is using for. So in here, this module will introduce the purpose and basic structural components of microprocessor and microcontroller. Okay, both of those. I think Ma'am Suarez wasn't able to include one. So it focuses on the different functionality of each component. Okay, so the first topic is of course differentiating what is a microprocessor and then what is a microcontroller and what are their parts, etc., etc. And then we'll talk about the structural components of a microprocessor. What is a control unit or execution unit? What is registers? What is internal CPU interconnections, or sometimes you call that one bus, interface unit. Okay. So at the end of this meeting, so you'll be able to define the purpose of microprocessor. You'll be able to identify different components of microprocessor, and then you'll be able to recognize the function of each component. So you only need, the internet right now. So, and then your computer or mobile device to finish the module, the week 1 and 2. Okay. So yeah, that's it for the topic learning outcome. And then, before having a discussion, so Ma'am Suarez provided a short discussion right here wherein you just need to identify your device. So is desktop, laptop, or mobile. And then what microprocessor, and just share it in the comment box below. So what is a microprocessor that is being used by your device? Okay, so if you have 3 devices, then just indicate each one of them. Okay, as simple as that. That's already 5 points. All right. So are we clear so far for your first discussion?
Yes, sir. Clear naman po.
So as much as possible, please respond as quick as possible so we can finish, our meeting as fast as possible. Okay. Anyway, this is just a short meeting since this one is more introduction. So let's proceed now to the intro to microcontrollers. Actually, there is one more activity right here wherein you're going to differentiate the microprocessor and microcontroller, but I just removed that one since we're going to have a discussion today. And then as you guys can see, it will be discussed on this module already, like what are the differences of microprocessor and microcontrollers. That is why I just simply removed that one. Okay, since we'll be discussing that one here today anyway. So let's start with the introduction to microcontrollers. So here are the components of a microprocessor and a microcontroller. So both of them have this one. Well, except for the microprocessor. So it's a different module. Okay, but of course you cannot make that a microprocessor work without the others. Well, anyway, so microprocessor has a CPU, of course, and input and output. We have the bus, the memory, which is RAM and ROM. We have the timer, the interrupt, serial port, and then the parallel port. Okay, so let's start by having this discussion with the general purpose microprocessor. So microprocessor is another term for CPU for computers. Actually, it's just a CPU. Okay, when we see microprocessor, just think about a CPU. That's about it. Okay, And then commonly, of course, since it's just a CPU, there is no RAM on it. There is no ROM. There is no input and output. And then, yeah, it's just a single chip, okay, which is just the CPU itself. Okay, so these are just additionals to make the computer work. All right, so I hope we're clear with the microprocessor. So it's just the CPU for computers. Okay, moving on to the next one, which is a microcontroller, wherein of course this one is it's also a chip wherein it has the RAM and ROM and I/O ports. Okay, so that I think that's the main differences. This one is just a CPU, and this one sometimes it doesn't have an input output ports. It has this RAM or ROM wherein there is this program that it will do upon putting that into a certain socket. But yeah, in most cases it has a RAM, a ROM, and then this one is optional. Okay, but yeah, some microcontroller also, or most microcontrollers also has an input output ports. Okay, so here are some examples of microcontroller. So we have here the Motorola 6811, Intel's 8051, Zilog's Z8, and PIC 16X. Okay, so if you guys would like to learn more about this microcontrollers, so feel free to search them on the internet. Okay, so this is a single chip which has a CPU, RAM, ROM, input, output, the timer, and then the serial COM port. So again, this one uh, makes or comprises this six parts to make one microcontroller. All right. So here are the differences. Again, microprocessor is just a CPU. It's a standalone. It doesn't have a RAM, doesn't have a ROM, doesn't have an output. So we are separated to the CPU itself or the microprocessor. So a designer can decide on the amount of ROM and RAM and input output ports, since of course it's a different module wherein we can choose how much big a ROM we can install to that. It's like building a computer. So how many gigabyte, or I mean terabyte, okay, of hard disk you want to install to that computer. Okay, how many RAM? Is it 16, 8, 32, 64, 128, okay, of RAM? And then for the I/O ports, well, of course, this one depends on your motherboard. Okay, and then similar with your case, okay, on how many ports does your case has. Okay, and for microprocessor, of course, this one is expensive, since as you guys already know, it's the CPU of the computer. Okay, and then of course, this one is versatile. This one is made for general purpose, so it can do a lot of things. So just think of our computer that as a general purpose device. And then of course, it's a high processing power. Okay, it's high power consumption. Instruction sets focus on processing intensive operations. While on the other hand, the microcontroller, of course, this one composes of CPU, RAM, ROM, input, output, and timer are all on a single chip. Now the problem with with this one right here is, of course, let's just see that of course they have these variations. For in this one has speed of this one has a uh, amount of memory of this one, amount of internal, let's say, hard disk of this one, and then a limited input output. So whatever is installed on that chip, you cannot change that one anymore, unless you do the re-engineering of the entire microcontroller. But whatever you have bought, let's say 8051, okay, or let's say Motorola 6811, by default, that's already the capability of that microcontroller. Okay, depending on, say, the needs for a certain device. Okay, so this is a fixed amount of on chip ROM, of course, fixed amount of RAM, and then fixed amount of input output ports. And like in here, you can change the RAM anytime, you can change the ROM anytime. Same with the ports. Okay. And then for this one is for applications in which cost, power, and space are critical. Since as you guys already know, microcontroller is this small like this one. So you can see that Arduino is one good example of the microcontroller. Okay, it has a port, it has this small RAM maybe, Okay, what else? And then other parts of it, which it can run just by putting a serial bus or connecting that one to computer. Okay. Then whatever you have programmed to the pins that it will do, then that is the one that it will do, depending on the program that you have put in there. Okay, so this one is made for single purpose only, unlike this one is general purpose. Of course, this one is low processing power since this is a small device, low power consumption at the same time, and then bit level operations, and then instruction sets focus on control and bit level operations only. Okay, so basically those are their differences. Again, microprocessor is just the CPU. Okay, that is the CPU for computer, and then microcontroller is composes of those uh, let's say RAM, ROM, etc., etc. Okay, so it's a compact mini computer. Okay, when it comes to microcontroller. So are we clear so far regarding with the differences on what is a microprocessor and then what is a microcontroller? All right, so if ever that you guys have a question, so just let me know. Oops, sorry, there is more information about microprocessor and microcontroller. So let's start with this one right here first. So this one is typically 32 or 64 bit. Pretty sure that you guys are already familiar with this one. Okay, we have 32-bit operating system and then we have 64-bit operating system. And then typically deep pipeline from 5 to 20 stages. While on the other hand, since this is a smaller device code, this one can only take up to 16 bit. So it's either 8 or 16 bit. And then this one is typically a single cycle or two-stage pipeline only. Okay, sometimes it's just to send, and then if it's two-stage, then to send and then to receive. As simple as that. All right. So here are some popular microcontrollers. Again, we have 8051, we have the PIC right here, the Atmel AVR, and then the Texas Instruments MSP 430, which is the 16-bit. Okay, so there are many more. Okay, so these are just the popular microcontrollers that are being used nowadays. Okay, so in here we have again like the differences of microprocessor and microcontroller. So in a microprocessor, it's just a CPU, while in here we have this one is a complete package. Okay, so we have the I/O port, has the timer, the serial interface, etc., etc. So both of them is the heart of a certain system, but for this one microprocessor, it's the heart of a computer, specifically for computer only. Well, on the other hand, so it could be used in any system, so especially in embedded system. Okay. And again, a microprocessor is just a processor, and then they are not connected, or memory and I/O are separated. Okay. While on the other hand, so it includes external processor, uh, what else? Internal memory, and then input-output components. So what else? I think most of them are pretty much the same. Yeah, and then higher power, lower power. The microprocessor doesn't have the power saving, so if it needs 80 watts to 90 watts, then that's the power that it will eat up. Okay, while you're using that processor. While on the other hand, this one has the power saving mode. Okay, like if it's in idle, of course, it will go into power saving mode. And yeah, for the input output, so we don't have input output for this one. While on the other hand, we have input and output. And microprocessor have less number of registers, hence more operations are memory based. While on the other hand, microcontroller have more number of registers, hence the programs are easier to write. And then what else? Microprocessors are based on von Neumann model architecture, where program and data are stored in same memory module. While on the other hand, this one is based on Harvard architecture. Okay, so von Neumann for microprocessor and then Harvard architecture for the microcontroller. Okay, so where program memory and data memory are separated. And then this one is mainly used in personal computers for microprocessor, while on the other hand, this one is used mainly in washing machine and MP3 players or many more. Okay, not just those two. Okay, we have a lot more standalone devices right there that is using a microcontroller. Okay. So yeah, that's already it for the intro to microcontroller. So are we clear so far? Any question?
Clear naman po, sir.
So if you guys don't have a question anymore, I hope, then I guess we're gonna proceed to the module one. All right. So similar with what you guys have saw on the topic learning outcomes. So that this is it already for the page one. And then I will not go over with the differences of a microprocessor and microcontroller anymore. Let's just go over to the most important defining characteristics of a microprocessor. Okay, so take note, microprocessor. So in here, one very important characteristic of a microprocessor is a clock speed. So in here we only have two possible situation that will happen on the clock speed. So one is for ready signal, or the one that is processing working normally. Then the other one is interrupt, meaning it could be on pause mode. Okay, it's like not doing anything, it's not processing anything, or it encountered an error. Okay, as simple as that for the clock speed. And nowadays, it says here that currently microprocessors have a clock speed in the range of 3 gigahertz, meaning it can process also 3 billion cycle per second. Okay, but I think this one is outdated since the highest gigahertz or speed of processor that we can reach right now is 4.9 of microprocessor. So it's not 4.9 anymore. So it's actually already we have a new one before this one's EMD, but we have the Core i9 12900KS. So this is my first time hearing this one. It can run at a maximum speed of 5.5 gigahertz. Okay, so compared to what we have in this module, so it's only up to 3 gigahertz, and then saying that that is the maximum that the current technology can attain right now. So this is already outdated. So maybe this one was like 3 years ago, 4 years ago, or 5 years ago. So speeds more than this generate enough heat to damage the chip itself. Okay. So yeah, basically you just need to install a better fan. If not a fan, then you can just install a liquid. Because one, is that correct? Liquid all-in-one cooler, I guess. The weird. No, not this one. Mm, they call that one liquid cooler. Okay. So pardon me with this one since I do not know how to use a liquid cooler because I never experienced touching one, to be honest. Okay, I just saw fans just like this one, the all-in-one liquid cooler, but I think we have a better version of this one, which is the real liquid, this one right here, where it really pumps water. Okay, anyway, so it's their solutions not to overheat the microprocessor. Okay, another one is word size. So this is just the size that it can process by a microprocessor. So one word is equal to 4 bit. Okay, so it's just a conversion of a number system. So 4 bit size or one word size. So they are just the same. So so in here, word size determines the amount of RAM that can be accessed at one go and total number of pins on the microprocessor. So total number of input and output pins in turn determines the architecture of the microprocessor. So the first one, the first commercial microprocessor Intel 4004 was a 4-bit processor. Okay, so I think this is the oldest official microprocessor that we had. So it had 4 inputs and then 4 outputs, and the number of output pins is always equal to the number of input pins. So if we have 4 inputs, of course it will have 4 outputs also. So currently, most microprocessors use 32-bit or 64-bit architecture. Okay, until now, I guess. So before they started with 4-bit or one word, well, if you're going to convert this one into words, so just divide this one by 4. So how much do we have if it's divided by 4? 8, 16, 24, 22. So 8 word size or 16 word size. But since word is not, not that much used when it comes to sizes, so let they mostly use a bit, so they stick with a bit until today. So we have 32-bit operating system and then 64-bit my operating system. So the last one that is you know part of the most important characteristic of a microprocessor is in instruction set. So basically this is the uh, ALU or the arithmetic logic unit, wherein this is the part where uh, everything are being processed. Okay, so data transfer, arithmetic operations, and then logical operations, and then control flow, input output, and then machine control. Okay, so I hope we're clear with the microprocessor. For the microcontroller, okay, so again, it is a computer on a chip optimized to manage electric gadgets or a certain standalone device. So a microcontroller has those parts. We have oscillator, we have AC/DC converter, the microprocessor itself, and then of course it has a RAM, it has a program memory, and so on and so forth. Okay, so making that one as a microcontroller, this one right here. And then here is the structural components of a microprocessor. So number one, or the first one, we have the control unit. Second one, we have the arithmetic logic unit or the ALU. And then we have the registers, internal CPU, and then the last one is internal CPU interconnections. So basically in here, this is where the processors are, being made. And then this is the one controlling whatever is the input or output that is happening. So basically control unit is just converting, let's say if I press J or K or number one. So instead of receiving a number or a letter, this control unit is converting that one into a readable format, let's say binary or hexadecimal or what else. So yeah, with those type of number systems. Okay, so with that, the ALU now can process those combinations of numbers. Okay, but I forgot to mention before that. Okay, before going to the ALU, so all of those are actually going to the registers first. So they will be registered right here. So one by one, let's say bit by bit. Okay, before going to the ALU, and then after being processed, it will go again to the registers, and then will be fetched by control unit, and then it will now again move back to the output or as an output. Okay, so yeah, control unit or the execution unit which receives and provide outputs. ALU is the one performing arithmetic, logical operations, etc., etc. Registers is the one that data are being stored, okay, and so on and so forth. And then here is the figure for the size and types of the 8 general purpose registers of times 86 microprocessor, or let's just say 32-bit, okay, microprocessor. So these registers are usually the registers involved in assembly programming, okay, in your laboratory. So we have 3 parts right here for this 32-bit microprocessor, or sometimes we call this one times 86 microprocessor. The first one is the base pointer. The second one is the stack pointer, and then the rest, EAX up to EDI, is the one that we're calling general purpose registers. So we will explain those parts here one by one. So the first thing that you guys need to take note is probably this one. So the registers hold 2 types of data. So each register, let's say this part right here, can hold 2 data. So the first one is the operand, and then the second one is the data itself that is being stored onto that specific registers. Okay. Well, anyway, probably you will appreciate this one once you've done some programming. Okay, that wherein you're going to use AH or AL in in terms of using AX. So just do take note that AX has its own edge or advantages over BX, CX, DX. So the same with the others. Okay. So you can use them as a storage initially uh, for everything. But at the end of the day, they have their own edge. Okay. So it will be explained right here later on, the AX, BX, CX, and then DX. So for now, let's discuss the memory access registers. So this is a type of registers responsible in fetching data from the memory. So we have two types of that. One, we have the memory data register or the MDR, and then the memory address register. Okay. The second one is instruction fetching registers. So this is a type of registers responsible in fetching instruction from the memory. Okay. So basically, we also have two types of instruction fetching register. The first one is program counter or the PC. This one contains the address of the next instruction. The second one is instruction register. This one contains the instruction itself. Okay. And then we have a flag. So a flag is just a status, format for wherein if it's successful or no. Okay. So in here, it's just to show if the information or the status of the information. So we have the so-called program status word or the PSW. So one contains bits that are set by the CPU to indicate the current status of an executing program. So again, these indicators are typically for arithmetic operations, interrupts, memory protection information, or processor status. So we have four types of flag. The first one is, the status is being carried, or the status is, already overflowing, or if it's just a sign, or if it's zero, or if it's a parity. Okay. So that's it for the condition registers or the flag. The next one is the pointer register. So this one used to store a memory address. So all of them is actually 16-bit. The instruction pointer, stack pointer, and then the base pointer. So you guys will be able to see it right here. The base pointer, stack pointer, and then the instruction pointer may be around right here. Okay. So all of them are 16-bit registers. So for the instruction pointer, this one is associated with a code segment register. For the stack pointer, this one is associated with stack segment register only. Okay. And then for the last one, the base pointer, this one is also 16-bit, but this one is referencing parameters, data, or addresses that a program passes via the stack. Okay. And then we have last one as for the registers. We have segment registers. We have here a register point to a place in a memory where one of the following things begin. So we have here the data storage and then the code execution. So code segment, this one contains the starting address of a program's code. And then data segment contains the starting address of a program's data segment. And then the last one is the stack segment, wherein it permits the implementation of the stack in memory, wherein it's a temporary storage of address and data. And then for the last one, we have here the general purpose registers, which will be continued on the part 2 of this Zoom meeting, since we know we don't have enough time anymore. Okay. So sorry, I tried to finish everything in just one Zoom meeting, but it's not enough since I still need to explain, this activities that will be, given later on. Well, actually, it's already available, but I still need to discuss this one later. Anyway, so goodbye for now, and then I'll just announce a new link where you can join for our party. Okay. So goodbye for now, and then see you guys later.